But by no means are these recordings replacements for the lectures. Okay, you'll see that when there's activities, in order to get credit for any in-class activities, you physically have to be present. Okay, you can't make up activities. So that's one reason, to be here. Also, these recordings that I've been making now, this is the third quarter. I started doing this this past fall. But I can't guarantee the quality of these recordings. Okay, most of them come out pretty good. Okay. But there have been some in the past where the video quality isn't quite good. And there's been a few where my voice gets all garbled. And I don't know what caused it because I make the settings all the same. I always test out the audio before I get started. But I just want you to know up front that my reason for making these recordings is not to replace the in-person lectures. It's just a supplement. In case somebody's sick someday and misses a recording, or somebody wants to review something before a test or something like that. Okay, so I just wanted to put that out there because I don't want you to think, oh, I don't have to go to class. Perks records his lectures. Okay. Okay, so what we're going to talk about today are number bases and number base conversion, and we're going to focus on number base conversion, number bases that are particularly important in the digital world. Okay, so this is an intro to digital design, right? That's what we're interested in. Number bases that are particularly good to know for digital. What did I just write on the board? What did I just write? Numbers. Yeah, just numbers, just characters, right? But how many people automatically thought 123? It had to be some honest people in the audience, right? Yeah, we've been programmed when we see characters like this to think base 10, right? Because back when you first learned numbers, I don't know, when did they first start teaching numbers now? Yeah, first grade or even before first grade. Right? Whenever that was, when numbers was first introduced, you were told that even if it's not explicitly written, there's this dot. And what do we call that dot? The decimal point, right? And just to the left, that's the ones column, right? Then comes the tens column. Then comes the hundreds column, and so on. And then later on, I don't know how much later on, but later on you learn about powers, right? Base 2 power. Then we learn about powers. We learn that any base, like base 10, to the 0th power, the particular one, 10 to the 1 is 10, 10 to the 2 is hundreds, and so on. Then to the right of the decimal point, that's where you got the 10 to the -1, right? Your fraction, 10 to the -2, and so on. Right? So from an early age, you've been programmed to look at these characters, right? These numbers as base 10. And then how many characters do we have in base 10? How many? 10. Right? The number of characters. Characters. 0 through 9, right? So 10. Maybe count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Because 0 is a character. Well, these concepts, right? The number of characters and what the columns represent applies to all bases. No matter what base you have, the number of characters in that base equals the base. And no matter how many, what base you're talking about, no matter what number base you're talking about, this is the ones column. This is the base to the 1 column. This is the base to the 2 column. This is the base to the -1 column. This is the base to the -2 column. Okay? So in the digital world, a popular base is base 2, which is called binary. So how many characters do we have in base 2? 2. Right? Because the number of characters you have in a base is equal to the base. And does anyone know what the 2 characters in base 2 are? 0 and 1. Hello. What's your name?
Sean, with this.
Oh, okay. Go ahead, have a seat. I made a note up here for people looking at it. Yeah, so in base 2, we have 2 characters, 0 and 1. Every base you have to have character 0, because in every base you could have, nothing, right? And that's what 0 represents when we don't have it. Okay. So, somebody give me, binary 2 number, base 2 number. Just give me a string of 1s and 0s. Like, say, give me, I don't know, give me 6. 6. We call these bits, by the way. Okay, 1, 1, 0. Say it again. 3 more zeros. And I'll put a 1. Okay. So yeah, this is an example of a base 2 number. And even though it's not written, okay, even if it's not written, just like in base 10, we know that there's a decimal point there, even though it's not written. Now, in base 2, and in fact, in all other bases other than base 10, we don't call this a decimal point, right? Because decimal means base 10. In all other bases, we call this point the radix point. RADIX, radix point. Radix is just another word for base. And radix and base mean the same thing. So, in this binary number, this is the 1s column, right? 2 to the 0, the 1s column. Then this is the 2s column, 2 to the 1. This is the 4s column, 2 to the 2. That's a power. This is the 8s, 2 to the 3. This is the 16s, 2 to the 4. This is the 32s. Sorry, I'm making my powers not very good here. 2 to the 5. And this is the 64s column, 2 to the 6. So, just like 10 to the 0, 10 to the 1, 10 to the 2, you have 2 to the 0, 2 to the 1, 2 to the 2, and so on. And just like as you go from column to column, there's a factor of 10 in base 10. In binary, as you go from bit to bit or column to column, there's a factor of 2. Right? 1, 2, 4, 8, 16, 32, 64. So that would be 128, then 256, then 1024. You can keep going. Okay, and then on this side of the radix point, you'd have 2 to the -1, which is how many halves, 2 to the -2, how many quarters, and so on. Okay, does that make sense? Okay, now another base that's not quite as popular as binary, and also the next one we're going to do after this one, but still comes up sometimes in the digital world, is octal. Okay, which is base 8. So how many characters in octal? Base 8. 8, right? Because again, the number of characters in the base is equal to the base. Does anyone watch Jeopardy? The game show Jeopardy? Nobody watch? A few people nodding their heads. I don't know, people nowadays are almost like ashamed to say they watch Jeopardy. Jeopardy's cool, right? You gotta be smart to be good at Jeopardy, right? Well, if you ever watch Jeopardy, sometimes they have a category, stupid answers to stupid questions, where the answer is in the question. Right, so that could be a question under that category, right? How many characters in base 8? Well, base 8 has 8 characters. And what are those 8 characters? 0 to what? 0 to 7. A common error people make is they'll think 0 to 8, right? They'll think that 8 is part of base 8, but remember, 0 counts as a character. So, you could have a base 8 number like this, say like 531.7. So what would this column be worth? This one right here to the left of the radix point. That would still be the ones column, right? It's 8 to the 0, right? Any base to the 0th power, you learned a long time ago, is 1. What would this column be worth? 8, because 8 to the 1, right? So this would be your 8's column. And then how about this column here? What would that be worth? What is it? 64s, right? Because it'd be 8 squared, right? This would be the 64s column. Then how about here? Just to the right of the radix point, what would that column be worth? 8's, right? Because 8 to the minus 1. Right, 8 to the minus 1, so this would be the 8's column. Right, so you're seeing how whatever base you have, it goes back to what you learned in base 10, right? It's just, again, you probably don't remember this because it was so long ago, right? But you see that how it connects back to what you already know? Okay, so base 2 is very important for this class. Octal, not so important. But the next one is also very important, just like base 2. And that's hexadecimal. Or just hex. Hexadecimal, just hex. Hexadecimal, that's base 16. So how many characters in hexadecimal? 16. Does anyone know what those characters are? 0 through F, right. The first 10 are the same as base 10, 0 through 9. Okay, but then we need 6 more, right? So once we get to 9, then we start using letters. A equals 10, B equals 11, B equals 12, B equals 13, E equals 14, and F equals 15. Now you can see I use capital letters, and most of the time when you see hexadecimal and it gets to the letters, most of the time they are capitalized. However, it's not like something that's strict. You'll sometimes see hexadecimal characters in lowercase. In fact, there's a lab later on this quarter that because of a limitation of a type of display that we're going to be using, we will have to use lowercase for some of those hex characters. And when we get to that part of the course, it's not for a few weeks, you'll see the reason why. But also in the class that's the follow-on to this class, okay, CPE133, okay, the follow-on to 133. In that class, you'll be using hexadecimal as well as binary, a whole lot. And in that class, sometimes you'll see in hexadecimal when you get to the letters that they're lowercase. But most of the time, you'll see them in uppercase like I've written. Okay. All right, so let's say you had, I don't know, somebody give me a hexadecimal number. Give me 4 characters, and then, well, 4 characters to the left of the radix point, and then like 1 character to the right of the radix point. So what do you want the first hex character to be? 1. 1? Then what? Not another one. 5? Okay, how about some letters? E, E, okay. What was over here?
A.
A, okay. And then the radix point, and then give me another character.
C.
C. All right. So we have a base 16 number like this. This column here with a is, what is that going to be worth? 1. See the column to the left of the radix point, it's always the ones column, right? Because any base to the 0th power is 1. So this is always the ones column, right? It'd be 16 to the 0. Okay, then what would this column be worth? 16. This would be the 16's column. Right, 16 to the 1. Okay, then the next column. Just 6? 256. Oh, 256. Sorry, I didn't get it. Yeah, 250. That's the 256 column. And why is it the 256? What did you do? 16. Yeah, 16 squared. Okay, and then how about this column? What would it be worth? Yeah, 16 cubed, right? And what is 16 cubed? Is it 655? What's that? Yeah, I thought it was 4,096. I think maybe the next one is 4,096. Okay, whatever 16 cubed is, I'm pretty sure it's 4,096. Right, if we take 256 times 16, that looks reasonable, be around 4,000 something, right? Okay, how about this column just to the right of the radix point? 16ths, right? That's the 16 to the minus 1, so that's the 16ths. Okay. So, any questions up to this point? Is it all making sense? Everybody's good. You know, there was a book that was a bestseller. It might have been like 10 years ago. When you get old like me, 10 years ago doesn't seem that long ago, although it's like half your lifetimes, right? But anyway, there was this bestseller not that long ago, 10 years ago, that was called "All I Really Needed to Know Is What I Learned in Kindergarten." And it had things like this, you know, because really to understand any base, you just got to remember when you were first taught base 10, right? Because all the concepts that you were taught then apply to all these other bases. Okay, now, by the end of this class, and I would say maybe even in a few weeks, you're going to start to see why base 2 is important for digital. And you're going to start to see why hexadecimal is important for digital. Okay, but right now, just kind of take my word for it. That these two are really important for this class, and also CPE133, and also any other class you deal with that's got digital information. Okay. All right. If there's no questions on this, I'm going to erase what's up here, and we're going to do some base conversion. Okay, because you know you often have to convert from base 10 because that's what we think. Right? We think base 10. But you often have to convert base 10 into what computers use, which is binary, and also hexadecimal. And also it's advantageous to be able to convert between like binary and hex and back and forth, right? So we're going to do some examples of converting between these bases. Okay? All right, so I'm going to erase this. So no questions about what's already up here before I erase it? All right. All right, so let's start with going from base 2 binary to base 10. All right, so give me a binary number. Just give me a string of ones and zeros. What do you want first?
0.
0.
0.
What's next?
1.
1. 1.
1.
1. 1. Everyone stepped on 1. 0. Okay, thank you. It's 0. And, let's put a radix point, and then what do you want this bit to be? 0, and we'll put a number, right? Now, one way to identify what base your characters are that you just written here, because this could be some other base other than base 2. Well, to make sure to explicitly indicate that this is a binary number, we'll put a little subscript 2, right? So this makes it clear that this is base 2 binary. Okay. So when I do a conversion from base 2 to base 10, I just think of the columns, what the columns are worth. As we said earlier, this is the ones column. This is the 2s. This is the 4s. This is the 8s. This is the 16s. This is the 32s. This is the halves. This is the quarters. And now, wherever there's a 1, you have that value. Wherever there's a 0, you don't have that value. Right? So you see, we don't have a 32. We have a 16. We have an 8. We have a 4. We have a 2. We don't have a 0. We don't have a half. We have a quarter. And now you just add up the ones columns. And by the way, when I'm doing this, if I make an error, not only this class, anytime this quarter, if I make an error, please tell me. Don't let me keep going on. If you know I've made an error, don't be shy about, hey, you made it. I don't make errors on purpose, but I do make errors. So, all right. So let's see, we got 24 here, right? Then 28, 30. So it'd be 30 and a quarter. 30.25, if you will. Right? We could put subscript 10, just that again, to make sure explicitly say that's a base 10 number. Okay. Does that all make sense? Do you want me to do another example, or is this good? Good? Okay, so that was going base 2 to base 10. Let's do base 10 to base 2. Okay, go the other way. So give me a base 10 number. Don't be too crazy. Don't give me like a billion, something like that. Give me maybe something in the thousands, let's say. What do you want? 1337. Okay, so 1,337 base 10. We want to put that into base 3. Now, I'm going to show you how I would do this conversion. There are different ways to go from base 10 to base 2. In fact, previous classes I've had, some students have had some of this at their high school, and there's a very common algorithm that some people know from high school. And if you know that algorithm and you want to do it that way, that's fine. Okay, I'm just going to show you how I would do it. Again, it's using what I know about columns. So in base 2, again, we know that we have the 2 to the 0, right? The 1's column, and the 2 to the 1, the 2's column, right? And so on. So, 4's, 8's, 16's, 32's, 64's, 128's, 256's, 256's, over here, 512's. These are S's, by the way. Let's see, 1,024's and 2043's. So you see, what I'll do is, I'll write out my columns until I get to a number, a value of a column that exceeds the number that I'm trying to convert. So, see, I drew out all my columns, right, for my bits, until I got to 2048, because I know there isn't any 2048s in 1337. So you see, I know that bit, right, this bit here. Would be the what, this is 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, 2 to the 8, 2 to the 9, 2 to the 10, 2 to the 11. So you see, when I get this to the 2 to the 11th bit, right, I know that's gonna be 0 because there's no 2048s in 1337. But I do have 1024 in 1337. So you see that bit would be a 1. And then I would take that value, right, 1024, and I would subtract it. Alright, so after we subtract this, we're gonna get what? 313. So now I'm looking at 313. Well, there's no 512s in 313. So that bit would be a 0. Let's say there's no 512s, but there is a 256 in 313, right? So you see my 256 bit would be a 1. And then I would subtract 256. Okay, and then what are we gonna get here? Is that gonna be 47? Let's see, 44 would give me 300. No, 57, right? Does everybody agree that's 57? Yeah, if I make an error, let me know. All right, so now we got 57, so, okay, we're at the 128 column. There's no 128s in 57. There's no 64s in 57. But there's a 32. Right, so you see the 32 bit, that would be a 1. Okay, let's see, this would be 25. Okay, let's see, there is a 16 in 25. 16. There's an 8 and 9. And I'm just left with 1, so there's no 4s, there's no 2, but there's a 1. Right, so 1 0 1 0 0 1 1 1 0 0 1. In binary is equal to 1337. Okay. You know, the algorithm that some people use is that, like, you take the number and you divide by 2, and if there's a remainder, that bit is a 1. If there's no remainder, it's a 0. Does anyone know that algorithm? Oh, okay. So nobody here, I guess they didn't in high school. But some people, like I said, in high school, they learn that algorithm that works also. But anyway, this is the way I like to do it, just because it's using what I know about columns and bases and so on. Okay? So, is everybody good here? Does anyone want to do another example from base 10 to base 2, or does it make sense? Okay, how about you now go from base, let's see, what do we want to do next? Base 16 to base 10. So this is X. Base 16. Base 10. Okay, so give me a base 16 number and include some letters. B, A, what was it? B. Oh, you want another B? How about give me a non-letter? Say it again. 1 0. And then we'll do like point E or something. Okay, so this is base 16. Okay, we want to go to base 10. Well, again, using what you understand about columns, this would be the 1s column, this would be the 16s column, this would be the 256s column, this would be the 4096s column. Then I double check this because this is 16 to the 4th, right? I'm pretty sure it's what a person said earlier, like 65,000. Is it 65,000? I want to have a calculator that they can do 4,096 times 16 real quick. I think it's like 65,553, something like that. on their calculator or the computer. Or maybe it's 5 by 6.
65,500.
5 what?
530, sorry, 5.
30?
536.
Oh, 36. All right, that sounds, thank you. All right, but it's whatever 16 cubed. And then this would be the 16th. Okay, so now you just take what each character is worth, right? The column tells you what that column's worth, and then just multiply it times, you know, what that character represents, that number that that character represents. So what is C in hexadecimal? It's 12. So we'd have 12 times 65,536, you know, whatever that equals. Then what's A in hexadecimal? 10. So then we'd have 10 times 4,096, whatever that is. Well, that one's easy, right? That's going to be 40,969. Okay, and then what's B worth in hexadecimal? 11. So that'd be 11 times 256. And then we'd have 1 times 16, and then we don't have any ones, right? It'd just be 0 times 1. And then we would have, well, what's E? What is it? 14. So then we'd have 14 times a 16. Right. So you just have to multiply these out and then just add, right? This is going to be 16, obviously. It's going to be 0. This is going to be what? 7/8. It's 14 over 16, 7/8. Let's see, that's going to be 25, 13 plus 256, so 25, 16, 256, right, this is going to be 28, 16. I did that right? Is that right? I think that's right. Okay, how about 12 times 65,536?
736,000.
Okay, say it slowly.
786.
786.
432.
432. Thank you. All right, then you just have to add all these up. Okay? Right, does that make sense? It's just following the same concepts as what we did earlier, right? It's just we got a different base. Okay, we can also go from base 10 to base 16. So give me a base 10 number. Again, something not too crazy. How about something in the 10,000s range? 40 9 what? 90. So this is base 10. We want to go to base 16. All right. Well, similar to when we went from base 10 to base 2, you know, I write out the columns. Right, write out the columns for base 16. So again, 16 to 0, that's how many ones, 16 to 1, how many 16s, 16 squared, 2 56s, 16 cubed, that's the 4,000. That's the 4,096s, right? And then the 16 to the 4, that's the 65,000, what was it, 536? All right, you see, I would stop there because I know there's no 65,536 in 40,980, right? So that would just be 0. All right, so now how many 4,096s are in 40,980? Actually, that's pretty easy to do, right? Because if we just multiply 4,096 by 10, that's going to give us this minus 20, right? It'd be 40,960. So there's 10 4,096s in 40,980, right? So 10 times, right? 10 times 4,096 is going to be 40,960, correct? Let me see, what would this character be? A. Because A is 10 in hexadecimal, like we said earlier. So now we just got 20 left over. So there's no 256s in 20. That would be a 0. There's 116 in 20. Right, so we go minus 16 here. And then there's 4 left over for the one. Right? Okay, so 40,980 in base 10 is equal to A014 in hexadecimal. Everybody agree?
Should that be 0, 0, or
Where are you looking here?
2, 6, I don't know.
Yeah, this is 1 because at this point we've got the 20. So yeah, we're just saying that there's 116 and 20. So that's why that's. Right. So everybody's good. Okay, so just a few more conversions here. It should only take maybe another 10 minutes, and then I'll give you the activity to work on. Then after that, well, you can take a break before the activity, and then once you're done with the activity, we'll continue on with the agenda. But there's 2 other conversions that I want to show you, and they involve going from hexadecimal to binary and vice versa. And in these conversions, we go directly from hex to binary and directly from binary to hex without going through base 10. Okay, and in this technique I'm going to show you, very useful. Okay, especially for CPE133, okay, the follow-on class. I mean, it's also useful for this class, but especially for 233. Okay, so before I show you how to go from base 16 to base 2 and vice versa without going through base 10, any questions on this? Because I'm going to erase it. Okay, so this is base 2 to base 16 without doing base 10 first. Right, because we did base 2 to base 10. That was one of the earlier examples, and we did base 10 to base 16. Right, that was an early example. So you could do this by going through base 10 first. Okay, but I want to show you a technique where you can do it directly because it's just simpler and very useful. And what I'm about to show you is based on that 2 to the 4 is equal to 16. Right? If you take 2, raise it to the 4th power, 16, as you all know. Okay, well, let's say I have this binary number. Let's say I have okay, let's say I have that binary. Now, again, I could take this binary number, go to base 10. Then once I have base 10, I could then go to base 16. Okay, but because we have this relationship that 2, which is binary, right? 2 raised to the 4th power gives us 16. I can do the following and get the same answer. And that's starting with the least significant bit. Group the bits in groups of 4. So I'm going to group these 4 bits together. 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 And by the way, like if that 0 wasn't there, you would just put it there because, of course, adding 0 to the left isn't going to change the value.
Is it always groups of 4, or is that because that's the power 2 raised to?
You got it. Right, right. The reason why it's groups of 4 is because of this. Yeah. Okay. So now, after you group the bits in 4, you write each 4-bit group as a hexadecimal character. So I'm just looking at these 4 bits. This is the ones column, this is the 2s, this is the 4s, this is the 8s. So what is 1010 in hex? A, right? Because we have an 8, we have a 2, which is 10, and in hex, a 10 is A. So you see, this would give us A. Okay, then I look at the next 4 bits, and again, this is the 1s column, this is the 2s, this is the 4s, this is the 8s. Now we write the hexadecimal character for this 4-bit group. And what would the hex character be for this? 7, right? Because we have a 4, we have a 2, we have a 1, so 7. Okay, and then I do the same thing here. What would this give us? We don't have a 1, we have a 2, we have a 4, we have an 8. I heard C. Any other answers? I heard D. E is E, right? There's 1, 2, 4, 8. So 14. 14 in hex is E. Everybody see that? Okay, and then what would this 5? Again, 1, 2, 4, 8. You have a 4 and a 1, so 5. So 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 1, 0 in binary is 5E, 7A in hex. Now, if you don't believe that this technique works, well, on your own, because we did an example like this, on your own, take this base 10 number or base 2 number and convert it to base 10. Take this hexadecimal number, convert it to base 10, you're going to see they give you the same number. Okay, and it's all based on this relationship. And also, you start to see the reason why hexadecimal base 16 is useful in the digital world. Because often in the digital world, you'll have data that's a lot of bits. That's a lot of zeros and ones. Like in fact, CPE133, the follow-on class, in that class, you're going to build a microcomputer that's a 32-bit microprocessor. And what's meant by a 32-bit microprocessor is that the data that that microprocessor processes is 32 bits. What would you rather say? 32-bit number, right? 32 zeros and ones? Or less hex characters? In fact, how many hex characters would represent 32 bits? But how many hex characters do you need to represent a 32-bit binary number? 8. Right? Because each hex character represents 4 bits. So instead of saying 32 binary digits, right, bits, you could just say 8 hex characters. So you see, that's why base 16 is popular in the digital world. It's basically shorthand, right? Because each hex character represents 4 bits. I don't think on modern computers, unless you know how to go into like the DOS level of the computer, which I imagine many of you know because you're computer engineers. But back in the day, this is back like in the 90s, again before you were born. When you booted up a computer, on your screen before it would get to where the user would have control, like the desktop, it would actually show the testing that the computer was doing before it would give control to the user. So, that's all the same, any computer's like that, right? When you first boot up, it's going to do some tests, like it tests out your memory and it tests out peripherals and stuff before it gives control to the user. But you don't see the tests happen. It's all like hidden. But in old computers, you would actually see it. It'd be on the screen. And what would it look like? You'd see all these hex numbers. It'd be like F, 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 A, B, C, D, and then, and it would just scroll through really quickly. And what was happening is the computer was doing all these tests, like checking out memory and different locations of memory. And you'll learn in CPE133 that, memory has things called addresses, which are just represented by bits. And when the computer was running those tests, it was just showing the hex of all the bits. Now, you can also go the other direction, right? This is base 2 to base 16 without going through base 10. But we can go the other way also. Okay? Like, give me a hexadecimal number. Let's say 4 characters. Don't give me the same one. Give me something good. Okay, D6 what? 5D. Let's not use a 5. Let's use 4. And a B. Okay. Okay, so 4D. Okay. Well, to go the other way, it's just each hexadecimal character you represent as a 4-bit binary number. So what's 6 in binary? 0110 is 6 in binary, right? Well, 4 bits. It's gonna be 4 bits. Okay, how about D?
One, 1,
1101. Okay, everybody know why it's 1101? What is D equal to? 13. Right? So you see, we have an 8, we have a 4, we have a 1. So 1101 is 13. Okay, how about B as a 4-bit binary? 1011. Because B is equal to what? 11. So we have an 8, we have a 2, we have a 1. And then 4 would be what? Right, 0, 1, 0. So 4B, B6, and X is, now you wouldn't have to say this 0 here. It's 1, 0, 0, 1, 0, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0. And again, if you don't believe me, convert this to base 10, convert this to base 10, you're gonna see it's the same number. Now, let me ask you this. What if we wanted to go from base 2 to base 8 without doing base 10 first? Yep, I heard the answer. Yeah, what could you do? I heard the answer over here. Yeah, group by 3, right? Because 2 to the 3 is equal to 8. So now if we took the same binary number that we converted to base 16 by grouping in 4s, if we took this and started again, you always start with the least significant bit. And you did groups of 3, and then you write each group of 3 as a octal character, you're going to get base 8. Yeah, least significant bit, just like when you write a base 10 number, right? This is understood to be the least significant digit. Same thing in any base. Whatever is furthest to the right, that's understood to be the least significant character, whatever base. And then, the character that's furthest to the left, that's called the most significant bit. Okay. All right, so I think with that, you're ready for the activity. So, well, any questions about anything at this point? Oh, 8 to 16. Well, I think most people would just go through base 10. Yeah, if it's not like base 2 to base 16 or base 16 to base 2 or base 2 to octal and octal to base 2, although like I said, octal's not as important But again, this class, base 2, base 16, of course, base 10, that's what we think. You know, that's primarily what we use. So if it's any other conversion, like base 8 to base 16, or say for some reason you wanted to do base 5 to base 7, you know, something like that, you would go through base 10. Now, you know, I'm sure there's algorithms out there that have like tricks, you know, for different base, you know, but generally speaking, you know, I think that's how most people would do it. So any other questions? All right, so let me give you what the activity is, and then you can take a break if you want. Now, when we do the in-class activities, in fact, let me write this down here to make sure it's not misunderstood. So, just about every class is going to have an in-class activity. Okay, usually, you know, usually the way the class will flow. Now, there'll be some exceptions to this, but most of the time, I start out with the lecture. Usually it's about an hour. You know, some lectures might be a little longer, some might be a little shorter, but they probably average about an hour. Then after the lecture, there's a in-class activity. Usually those in-class activities take about an hour. Again, sometimes they're a little shorter, sometimes they're a little longer. And then the last hour of the class is for you to work on the lab. Okay. And the only homework in this class is any lab work that you don't finish. Okay, that's the only homework. Okay. So for in-class activities, and I mentioned this earlier, you have to be physically present. Okay, to get credit, you have to actually be here. There's no like making up an in-class activity. Now, if you're absent for a university recognized reason that's documented, like for example, you're not feeling well, you know, if you're not feeling well, now actually, are they still doing the COVID, like the green pass? Did they stop doing that? So they've totally stopped now. It's not like last quarter, somebody was telling me it was still kind of like optional or something, but have they like disbanded it?
I think they still send the emails and you can still ask for them, but I don't think they'll do.
Okay. All right. Well, when COVID was going around, when COVID was, you know, present, whatever, and they had that system, you know, a red camp or a red, whatever they called it, the little badge thing, you know, that was equivalent to a doctor's note. But since they don't have that any longer, if you're not feeling well, just get a note from the health center or a doctor's note or something, and whatever you missed, it just won't count.
I think online they said you could just like screenshot it.
Yeah, that's fine. Yeah, like the health center. Yeah, it can be a note or like you said, your appointment. That's fine. You know, other common things, like if you have some university activity, like you're an athlete or you're in the band or, you know, something like that, you just send me something from, usually like for athletes, there's something from like the athletic director that excuses you, you know, there's like letters, you know, things like that. So anyway, if you go to the Cal Poly website, they have like a whole list of recognized excuses. All right, so it'd have to be something the university recognizes, and then just some documentation just to show that that's what it actually was. Okay, but anyway, for the in-class activities, you gotta be physically present. Each student does their own work. Okay, also you have to show your work. Right, because for the in-class activities, I give you the answers. Okay, so you're given the answer. So if you just write down the answer, I don't know if you just wrote down the answer or if you really know how to do it. All right, so you have to show how you get the answer. And actually, this is good practice for the midterm. Okay, because when we have the midterm, and it's not for like 6 weeks. But when I grade midterms, I don't grade on answers. I grade on work shown. So there can be somebody that has a correct answer with, or well, I should say, there could be someone that has an answer that matches mine, but there's absolutely no work, and I don't know where that answer came from, and that gets 0. Right, because I grade on work shown, I don't grade on an answer. There can be another person has an answer totally different than mine, like nowhere close. And I look at their work, and the only reason why their answer is way different than mine is they made a silly math mistake, right? They added 3 + 2 and got 7, something like that. That person gets either full credit or, like 99% credit. Okay, so this gets you in the habit of showing your work, because on a midterm, you definitely want to do that. Okay. All right, so physically present, each student does their own work, you gotta show your work. Now, because I give answers, it's graded on completeness, not accuracy. Graded on completeness. Not how accurate it is. Okay, because I'm giving you the answers, right? That's why if you just want to put down something that doesn't make any sense, well, that's up to you. That's not going to work on a midterm. And then the other thing is, it's just one submission per table. So whatever table you're sitting at, like this table over here, that's table 1. This is table 3, table 4, table 5, table 6, table 7, table 8. Now, how many people have had a circuits class? Oh, not that many. How many EEs do we have? So not all the EEs have had a circuit class yet. Don't you take a circuits class your first quarter with the what is it, EE151?
Oh, yes.
All right. So people that have had a circuits class, you know what an IC is, right? Like an integrated circuit, right? You know the ICs, they're black rectangles. They have pins. Like say you have an IC with 8 pins. How do you tell where pin 1 is on an IC? There's like a little marking, a dot. Like sometimes there's a dot, sometimes there's a keyway. So if the keyway is like this, and say there's a dot there, where would pin 1 be? Right, this would be pin 1, right? And then it'd be 2, 3, 4. And then where's pin 5? 5, 6, 7, 8. Hey, you're learning little circuits along with the table, right? So you see, that's how the tables are. So you just imagine this is an IC, and the keyway is up there. See, pin 1. Well, we're not using that table, but pin 1, we're not using table 2, but then 3, 4, then 5, 6, 7, 8. So it's just like an IC. So if you don't know what table you're at, that's pin 1, and just think about an IC. Okay. Now, I don't want to scare anyone that hasn't had circuits. You don't need circuits to do well in this class. Every once in a while, though, I will mention some circuit things that kind of tie into the class. Okay, that's because I taught circuits for a long, long time. So I just kind of like it. So, but yeah, you're not going to be tested on anything circuit related. So everyone's working at their table. So, when you're doing the activity, it's a group effort. You can collaborate, you can help each other, you can ask me questions. Okay, mainly what the activities are is practice on what we've already talked about. Okay, and then the lab part, which is the last part, that's applying what I've talked about and what you practiced. Okay. So it's just one submission per table. Not everybody's going to be turning theirs in. Okay, and how you want to submit it is up to you. Like you can choose a person at your table and say, hey, let's submit yours. Or you can submit like a couple people's and say on this one, look at these, on this one, look at these. However you want to do it, it's up to you. Okay. Now, for today's class, the people that aren't actually enrolled yet, okay, so the people that are looking to add, if you could like form your own group. Okay, so I think there was like 3 people, right? If you could be like a group today, and then, again, the people that are already enrolled, just whatever table you're at, that's your group. Okay, now the activity is actually on Canvas. Let me show you on the screen real quick. Okay, this is coming on here. So if you go to the modules on Canvas, and then if you click on the first meeting here, here's the activity, this activity 1. And if you click on that, you'll see it'll come up with, I think it's like 11 problems. They mostly like converting. Okay, so you see these 11 problems here, and like I said, the answers are given. So if you just scroll down, okay, these are the answers. So, do the problems, and then see if you get the same answers that I have. And if you have questions, help each other out or ask me questions.
So, submitting this is to like an assignment, or do you?
Yeah, with the activities, you can just submit a hard copy to me before you leave. Yeah, the activities you would have to turn in before you leave. Yeah, they're all, that's why it's called in class.
And then all of our names.
Right, yeah, you want to make sure that everybody at your table gets their name on it so they get credit for it. And like I said, for today, if you're enrolled, come sit at a table. Okay, so you know what group you're in. If you're not enrolled, be your own group. You can kind of sit in the back if you want, or you can come to this table and maybe sit on this end if you want. Okay, so to finish up today, I just want to, hit some highlights on Canvas, talk a little bit more about the course as a whole. And then it will lead into the first lab, which is lab 0. Okay, when you leave today, you'll be able to do like the first portion of lab 0. Now, if you don't get it done by next class, it's not that big of a deal because next class we'll talk about more of what you need to do, or more information that you need more to actually do the whole lab, okay, to finish lab 0. And lab 0 is pretty much an introduction to the software that you're going to be using throughout the quarter. Okay? So first thing, this is the home page on Canvas. Hopefully everyone's had a chance to at least look at this. I sent an email. Did you get my email? Like an intro email. Okay. So in the lab portion, we use this Basis 3 board, and we have one of these at each of the benches in the back. There's 8 benches in the back of the room, and each bench has a Basis 3 board. So even though I recommend that you purchase your own, if you don't have the funds, or you'd rather not purchase your own, we have these in the back. But of course, if you don't have your own and you use ours, they're first come first serve. So you may have to wait for one. If you have your own, you don't have to share, right? You don't have to wait because it's yours. This board is not only used in this class, but it's also used in CPE133. I think it's used in another class too. I'm not absolutely sure, but I know it's for sure used in CPE133. So you know, the academic price is about $120. But if you look at it as covering 2 classes at $60 a class, that's not too bad. You also need a cable, USB to the micro B, I think it's called. They also sell the cable as well as the board on the digital website that you have a link to. Don't use a charging cable for the cable, it won't work. It looks like a charging cable, like for an Android phone, but the charging cables don't pass data. And you need this type of cable that not only passes power, but data also. Okay. I'll talk more about this board coming up. Now, also, in case you didn't know, College of Engineering does have like recommended computer specifications. Probably one of the biggest issues with Vivado, which is the software environment that we use for the lab portion, is that Vivado doesn't come with a Mac version. Okay, there's just Windows, and I think there's a Linux. So if you have a Mac, in order to put Vivado on it, you would have to run Windows on your Mac. And from what Cal Poly ITS has told me, the new Macs have a processor. I guess it's an M1. Anyone heard of what M1? And what Cal Poly ITS, what they've told me is that if you have a Mac with an M1, it's not going to run Windows. So you won't be able to put Vivado on it. And I guess Macs that are like a year or maybe 2 years old have that new processor. So I mean, if you have an older Mac, like my Mac's older, and I was able to boot camp my Mac and put Vivado on. Okay, but depending on how old your Mac is, you may not be able to put Vivado on in the first place. But even the older Macs like mine, sometimes it's a real pain to get Vivado to run. You know, well, back when I got that Mac, the electrical engineering department actually had their own ITS. They no longer have their own ITS, everything's centralized now. But even with my own ITS, it was really a chore to get Vivado to work. Because we tried VMware, we tried, what's the other one, VirtualBox, and it never ran great. You know, like it would run, but be very clunky and slow. And it wasn't until it was boot camped that it actually, you know, worked. And I wouldn't be able to do it myself. I mean, there's a lot of tweaking that they had to do to get it to work. So anyway, it's not to say you can't get Vivado to work on a Mac, but it's a chore a lot of the time. So we also have computers with Vivado in the back. So if you don't have a laptop or you have a Mac, but you can't get Vivado to work on it, you know, you can use one of our computers. But again, the disadvantage is it's first come, first served. And who knows, there might not be one available depending on how many people need them. So that's why it's, of course, the preference to have your own laptop with Vivado on it, because that way you don't have to be in this room to work on it, right? You can work it on it at home, and you know, of course, it's much more flexible. I always tell students, if you have a choice, like say there's a PC, like a family member or friend has a PC that you can use, you know, I would recommend using a PC. But you know, we have information about how to you know, install Vivado. If you haven't done it yet, please do that as soon as possible, because you may run into issues. At the very least, Vivado takes a while to download and install, but often students run into issues. Now, if you run into an issue, now, there are some common things. The most common reason people have trouble installing Vivado is they don't have enough memory space on their computer, not enough free memory. When it installs, it uses a lot of memory. I think it's like 100 gig or something. It's a ridiculous amount. Okay, so if you're pressed on memory, that's probably going to be a problem. The other thing you don't want to do is nowhere in the path name do you want spaces. Okay, Vivado doesn't like spaces in a path name. So like when you're putting in a folder somewhere, you know, don't put a space in the folder name. And that goes also with when you're naming files within Vivado, never use spaces. I would avoid special characters also, except for an underscore. Like I've used an underscore and I know that's okay. But, yeah, Vivado can be very, particular. Okay. Let's see, other problems that sometimes come up is, I've heard students tell me that in order for them to install Vivado, they have to temporarily shut off their antivirus software because it didn't like something, and I don't know, so that's something else. By the way, before I forget, Kathy, in the back there, Kathy is the instructional student assistant for this class. She was a student in this class. How long ago, Kathy, did you take this? Was it last year? Last summer, and you've had CP233 now too, right? Yeah, so she not only took this class and did very well, but she also has taken the follow-on class, K233. So she's very knowledgeable. She'll be doing the grading of the lab work this quarter. I grade the activities, I grade the midterm, I grade the final project, but Kathy will be grading the lab work that you turn in. And she's here to assist. Now, as I mentioned in the homepage, this is a design class. Okay, has anyone taken a design class before? Whether it was in EE or CPE or something else, just anything where you had to design something? No one has? Like, a little bit? Yeah. Well, I would expect most people haven't had a design class yet. But the thing about design, no matter what it is design doesn't just happen. Design is typically a lot of work. All right. And in this class, it's a lot of work. There's just no way around it. Okay. Any type of design, it's always an iterative type of process where you start with what you think is going to work, and 9 times out of 10, it's not going to work the first time. It's just like when you build a circuit. For those of you that have had circuits, and you build a circuit on a breadboard, no matter how good you are at building that circuit, chances are when you hook it up the first time and you apply power to it, something's going to be wrong. Okay, so this class is a lot of troubleshooting. Okay, and Kathy and we're here to assist you through that design process and to show you like the best practices of troubleshooting, but we're not here to find the problem for you. Okay, so a lot of times when you come up to us and you're having some issue, we'll ask you questions like, well, did you check this? Did you try this? That type of thing. As opposed to looking down and trying to find like the actual mistake that you're making. Most errors are caused by syntax type things. Just putting a semicolon in the wrong place, or naming something not the right name, things like that. Okay, and you'll see that Vivado has like flags when you have some sort of error. Like, for example, if you have a syntax error, it'll put like a red squiggly line under where that error may be. Now, a lot of times the error is not on the actual line that it puts the red squiggly. It's like something close to that line. And it will give like error messages and warnings. Most of the time, the actual message itself isn't very useful. Error messages tend to be very cryptic. But what is useful is that in that message, it will usually give you the line where the problem is, or at least the problem is near. Okay, so I tell you that up front because when you come to us with a problem and we don't give you a direct answer, it's not that we're trying to be mean. It's that's the only way you're going to learn. The only way you learn troubleshooting is by doing. If somebody just tells you where the problem is, you're not really learning it. Okay, but like I said, we'll be here to assist you and also, teach you the best practices of troubleshooting. Okay. Let's see. Is there anything else on this homepage? Did you have any questions about anything on the homepage? How many people have downloaded Vivado already? Oh, wow, that's great. And the people that raised their hands, you were successful? Anyone that was successful with a Mac? Okay. I knew I went too far with that, right? We were going with all good responses, and I went too far. Okay, so, the syllabus, let's just look at some of the highlights on the syllabus. Okay, so, very important that this class, the format is what's called blended. What's meant by blended is a portion of the class is in person and a portion of the class is online. So the first 7.5 weeks is the in-person. So during that 7.5 weeks, like I mentioned earlier, the first hour is basically a lecture again. It can be a little longer, a little shorter, depending on what we're talking about. Then there's a class activity like you had today during the, second hour. And then when we're done with the activity, we go into the lab portion. And for the lab portion, you do not have to stay in the classroom. If you want to go work somewhere else, you want to go back to your dorm, or you want to go to the library or whatever, you can. Okay, now, one of the disadvantages of leaving the room is that I won't be here to give you assistance, and Kathy won't be. But some people, they get pretty confident, with the language, the programming language that we're going to be using, and they feel pretty confident. And if that's true, that's perfectly fine if you don't want to stay in the classroom for the lab portion. And like I mentioned earlier, the only homework is finishing lab work that you weren't able to finish during the class time. Okay. And the lab work will be in 2-person groups. Right, so remember the in-class activity that we just went through, that's per table. The lab work, it's going to be 2-person groups or teams. I'm not going to make the teams today, but Thursday we'll solidify the teams to start out with. Now we may change the team somewhere throughout the quarter. We'll just see how things go. Now, if there's somebody in the class that you've worked with before, or that that you work well with, and you want to team up with that person, that's fine. Just let me know on Thursday. Otherwise, I just randomly put people together. Sometimes what I try to do is put a CPE with an EE, just so you have kind of a mix in majors, But yeah, on Thursday, that's when we'll solidify the groups to start with. Okay, what I did in CPE133 last quarter that worked out pretty well is that we started out with groups, and then like 2 weeks later, I just handed out a piece of paper, and the student would just have to mark that they wanted to stay in the same group or they wanted to change groups. And the people that wanted to change groups, we made changes. The people that wanted to stay with the same person because they were working well together, well, they just stayed. Okay, so we'll probably try something like that. Okay. Like I said, for this lab 0, we'll decide the groups on Thursday. You can be thinking about that. Like I said, if there's somebody you want to work with, let me know on Thursday. Now, the online one, because like I said, it's a blended class. So the first 7.5 weeks in person, but then the last 2.5 weeks, there's an open lab. So the Thursday of the 8th week, that's an open lab where that's just a lab for people to either catch up if they got behind, or they can work ahead on the final projects if they're all caught up and they want to get ahead. But that Thursday of that 8th week is sort of like an optional class that you can come to or not, depending on whether you want to work on something to catch up or work on something to get ahead, or you don't want to work on it. It's up to you. It's optional. But then the last 2 weeks are devoted to final projects. There's a final project, but it has 2 parts to it. The first part, which is the 9th week, that's an individual effort. And then the 10th week, the second part of the final project, that's a team effort. And I'll talk more in detail about it as we get closer. So when I say online, what I mean by that is that I'm available for help when you're doing the final project on Zoom. Okay, so I won't be in class, and you don't have to be in class during that last 2 weeks. Now, this lab will still be open, so if you need to use one of our computers, or if you need to use a Basis 3 board, it'll still be available. But you're not required to attend class the last 2 weeks because again, it's devoted to working on your final projects. There's no new material presented during that time. Okay, so that's what I mean by online. There's no like online lectures or anything like that. Okay, so is that understood? Does that make sense? Okay, now I have Zoom office hours on Wednesday, 5 hours from 10 in the morning till 3. I prefer that you make an appointment, but if you can't, that's okay. But it's not like I sit at my computer for 5 hours. I just get on the computer if somebody emails me and say, hey, Gary, can we meet? And I can jump right on usually within, 5 or 10 minutes or so, or even quicker than that sometimes. And here's the link to the Zoom office hours. Let's see, what else do we have here? Yeah, if you have any questions about anything in particular, let me know. There's a text, but it's just a reference. Okay, there's no assignments out of the text. We already talked about the classroom protocol. Okay, graded work. Okay, we talked about the activities like we just did earlier today. Okay, lab work, there's 7 labs. Okay, lab 0 through lab 6. Okay, the due dates are typically on Mondays. That's when the submission is due. Now, it's two-person teams. Okay, each person does their own work. Okay, now this is very important because this is something that's come up the last couple of quarters, and I'm really going to clamp down on this. Okay, when you're working in your 2-person team, you've got to be doing your own thing. So, what has happened in the past? And I can understand how this can happen, by mistake. Is, 2 people are sitting next to each other, like side by side, and they're essentially just typing in the same code. Well, that's the same, in my opinion, that's the same as just like somebody looking over somebody's shoulder. Okay, so to prevent that from happening, either sit directly across from your partner, like say you two were a team, right? You're sitting across from each other as opposed to side by side. Okay, so I don't want team members to sit side by side. I want them to sit across from each other, or just sit in another part of the room. Like what some people did in some of my previous classes is, one team member would be here, and the other team member would go over on the other side of the room. They would still converse and help each other, but there's not a tendency for you to do the same thing as though you're sitting side by side. See, the only reason I found out about that, because I didn't even think that was possible, to tell you the truth, right? Because I told people, do your own thing, right? Don't look over somebody's shoulder. That you definitely don't want to do. If I see that, that's an automatic deduction of whatever you're working on. Yeah. But the way I found out about it is, they were working on an assignment, this one group, and one of the group members came up to me and they had kind of a strange kind of issue. So I asked them, I said, well, how about your lab partner? Oh, well, it's the same thing. And I'm thinking to myself, this is kind of weird for 2 people doing their own stuff to have this really weird issue, right? Well, the reason they were having the same weird issue is they were doing exactly the same thing. They were sitting next to each other and typing in this. That's not doing your own work, right? Obviously. Okay, so anyway, to prevent that from possibly happening, I want people sitting across from each other, team members, or like sitting in different parts of the room. Okay, if I see people sitting side by side in their team partners, and they're working on assignments sitting side by side, it's going to be an automatic deduction for that assignment. Okay, I'm clamping down on it, so you've been cautioned. Okay. Because the idea is if you're doing your own thing and this person's having a problem, they can go to the other person and say, hey, I'm having this problem. Let me look at, oh, that's what I'm doing wrong. See, that's why I want that the way I said it.
So these labs are not like group projects. It's just we have we got one person we can kind of like.
Right, exactly. Right. It's so you can learn from each other, right? You're not going to learn from each other if you're both doing the same thing, making the same mistakes, right? Yeah, that's exactly. Yeah. Okay, so each person's doing their own thing, right? Just like when you're doing the activity, each person's doing their own thing. And just like here, each table makes a submission. Well, each here, here with the lab work, it's just one submission per group. Okay? And you know, how you want to decide who submits what, if you just want to look at both of them and say, oh, yours looks better, or you know, you want to alternate every week, whatever you want to do, it doesn't matter. Okay? All right, so now, okay, and this is really important. This is the criteria for the lab work. There's basically 4 things you have to turn in. And I talked with Kathy, because again, Kathy's going to be grading this. And again, correct me, Kathy, if I get this wrong. But what Kathy wants you to do when you make a submission is she wants one PDF. Okay, and in that one PDF, you're going to have a link to a video that shows that your design works 100%. And this is really important. It's got to be 100%. It can't be 99.9% or any other percentage other than 100%. Okay, and we'll talk about what 100% means for each of the designs. For this first design, it's going to mean that on your board, it shows that your design gives the truth table that's given in the problem. There's like a truth table with 8 inputs that gives 8 outputs, and you got to show in the video that your design replicates that truth table. And it's got to be 8 out of 8. It can't be 7 out of 8 or 7.9 out of 8. Okay, and this is an all or nothing. It either works 100% and you get the full 3.5 points, or it doesn't work 100% and you don't get any points. Okay, now that may seem harsh, and it is harsh, but the reason why it's harsh is because when you take CP233, and let's see, did I bring my diagram of what we build in CP2? Okay, good. When you take the follow-on class, this is the microprocessor that you're going to be building. And this is probably an order of magnitude more difficult than the most difficult design you're going to do in this class. And when you build this microprocessor, these different components of the microprocessor, they have to work 100% in order for this whole thing to work. It can't be like this works 99%, this works 80%, and so on, because it ain't going to work all together if that's true. Okay, so you may think it's harsh, and it is harsh, but it's harsh for a reason. Okay, when you go buy a new car or something that's expensive, or even something that's not that expensive, you expect it to work 100%. Right? You don't expect it to work 99%. Okay, so in your single PDF, you want to have a link, you know, like the YouTube or Google Drive, you know, wherever you put your video. Okay, also, you want to show that you have a successful simulation. Now, you know, you'll learn exactly what that means as we go along, but that would be a screenshot. You know, like you'll have a screenshot of the successful sim. Then also, you want a screenshot of any errors / warnings. Now, this is true also if you don't get any errors or warnings. I mean, actually, that's the best thing. Like you do your design and you don't get any error messages or any warnings. But if that happens, you have to actually put the screenshot that shows you didn't get any. You can't just type, I didn't get any warnings or errors. You have to actually show that there weren't any. Okay? And then this thing called elaborated design. Schematic. So these are all screenshots. So it's a link to where your video is, and then screenshots all within this one PDF. Okay. Does that sound good, Kathy? Do you have anything else to add or? Sounds good? Okay. Also, very important. You can't miss more than one lap. Okay, somewhere here I have the late policy. Yep, right here. Like I mentioned earlier, the due dates are typically Monday. Now, just look on Canvas where you go to submit the lab and it will give the due date right there. I think they're all Mondays this quarter. I don't think we have any Monday holidays when things due. So they're due on Mondays. You can pass in lab work late, but you lose 10% every day it's late. Up to 5 days late. After 5 days, it's not accepted. It's just graded as 0. And you're only allowed to miss one lab the whole quarter. If you miss more than one lab, you're not going to get a passing grade in this class. And again, the reason why it's so strict is because when you take 233 to build that microprocessor, you have to have a successful design every week. It's not like you can put it off and then at the very end do everything. It's just not possible. Sometimes students try to pull a rabbit out of a hat. You've heard that expression, right? And it's just not possible in a class like this, or especially in 233. Okay, there's also a midterm. That's during, I believe, the 6th week of the quarter. It's a 1-hour test. The last 2 hours is a lecture. We'll talk more about that when we get closer. And again, here's the policy if you're sick or you have some university recognized excuse. Again, it's going to be documented. I give some examples. Now the grading. Okay, activities and attendance, because the activities also account for attendance. 15%. If you're consistently late to class, that will be deducted, prorated, so to speak. If you're late once or twice, that's not a big deal. But if it's something that's like almost all the time, then it starts to be an issue. Lab work is 35%. Like I said, there's 7 labs, so it's basically 5% a lab. The midterms a quarter, and then the final project, which again has 2 parts. There's an individual part, and there's also a team part. The reason why there's an individual and a team is because throughout the quarter you're working as a team with the lab work, but I want to make sure that's not one of those lab members is skating by. So that's why I have an individual part to the final project to hopefully motivate people not to try to just skate through the lab work throughout the quarter. Not that that ever happens a lot, but there's always 1 or 2 people, it seems, that, that's what they try to do. All right, anything else on here? I think, well, this is, if you're involved with the DRC, please let me know as soon as possible. And then, university policies about academic honesty and also accessibility adversity. You can click on those links for that information. So is there anything in the syllabus that you have? Oh, questions?
So there's no final exam, like written final exam?
Right, there is no written final exam, right? My feeling is, since you essentially have 2 final projects, right? I mean, it's really 1, but I split it up into 2, individual team. I think that's sufficient. Strangely, I found that some students want a final exam, but if you want a final exam, you can take a different section. Yeah, some people like final projects, some people like final exams. Some instructors give both, which again, I think is a little overkill. Let's see, what else do we have here? Okay, modules. So this is where you need to look for all the different resources. So in the lab, okay, where we have this basis 3 board, this basis 3 board the basic three board, it has an IC. And IC is integrated circuits for those of you that haven't had circuits yet. And when you look at this basic three board, there's these black rectangles, those are the ICs. One of these ICs is an FPGA. And FPGA stands for Field Programmable Gate. Okay. And essentially what's inside that IC is a bunch of different logic circuits. Now we're going next class to start talking about the components that make up logic circuits. Okay, these things called logic gates, and AND gates and OR gates and all kinds of different gates that we'll get to. And these different logic circuits, they're called CLVs, okay, configurable logic points. You know, there's a bunch of them inside this FPGA. So just think of these CLVs as just being, you know, various logic circuitry. Well, you'll be learning some software. Now, I already mentioned Vivado. Okay, Vivado, that's the software environment. And that's the company that produces the software, that's Diamond. And the company where you get the basis board from, that's Digital. So Vivado, that's the software environment. The language that you're going to be learning, okay, that models digital hardware, is System Verilog. Right, so you see, System Verilog is software, a code that models hardware. Okay, and you see, that's what's different about System Verilog compared to like a high level language like Python or C or any of those languages. You know, C language, you know, Python, you know, any high level language, the code that you write is instructions to a microprocessor. Okay, this micro with a P, that's my shorthand for microprocessor. In fact, when you take CPE133, in that class, you learn assembly language, which is not a high-level language. Okay, assembly is a low-level language. But assembly is also instructions to a microprocessor. That's not what System Verilog is. See, that's the first thing you have to really kind of get ingrained, is that when you're writing System Verilog, when you're writing that code, you are not writing instructions to a microprocessor. You're writing code that's going to model digital hardware. So the way to think about this System Verilog code is that that code selects out which logic circuitry you need for whatever particular design you're writing the code for. And in addition, that System Verilog code is making connections between that circuitry. So those of you that have had a circuits lab, like those of you that have had CPE151, or if you're a CPE student, there's some of the orientation classes that do some circuits like robotics and things like that. Well, if you've taken any type of class like that, chances are you've used a breadboard. How many people know what a breadboard is? Yeah, just about everyone. So you know with the breadboard, you plug in the components, and then you take wire, and you hook up those components with the wire. Well, that's what your code is doing. See, the code is actually, so to speak, building a breadboard within the FPGA, because it's picking out the parts, right, the logic circuitry that's needed, and it's also making the connections based on the software that you write. You know, when I took a class like this many, many years ago, decades ago, a digital lab was just like a circuits lab. We'd have a breadboard, we'd plug in ICs, we'd take the wire, and we hook up the IC with wire. But you see now, software can do it. Okay. Now, also, let me mention that we're using System Verilog. Some instructors that teach this class and some instructors that teach 233, they use Verilog. System Verilog is like Verilog 2.0. It's like a newer version of Verilog. It's actually a little bit more user-friendly, most people would agree, than Verilog is. But if you know one with very little added knowledge, you can do the other. Okay, so, you know, if you take CPE133 with a professor that uses Verilog, no big deal, even though we use System Verilog here, and it's vice versa. You know, if somebody learns Verilog in 133 and then they take somebody that uses System Verilog in 233, it's not going to be a big deal. In fact, most instructors would let you use whatever you used in 133. When I teach 233, if there's students that learn Verilog in 133, I'm like, oh, yeah, fine. Just use Verilog. That's what you're used to. Okay? All right. Okay, we only have 5 minutes here. I think we have just enough time to just look at the first part of Lab 0. Now, you know, when you get a chance, make sure to look at what's available under module. Okay, this is all the meeting stuff. I'll be posting the recordings that I did during class. The meeting here. There's a bunch of stuff. This here, you know, the lab instruction. Also, the lab demo criteria that I talked about earlier. You would say that Word file. Here's the intro to the Vivado video that I mentioned in the email. Your test cases you'll need later on. For each lab, there's instructions along with an intro video. And more lab resources. And this is where you commit to lab work on your lab assignment. And the final project's not for a while, so you don't have to worry about that for later. On the project stuff. So let's go back to the Meeting1. And then here's the Lab 0 Part 1 assignment. You're going to see it's basically what I had in the email, so it's nothing really new. It's just before we meet on Thursday, if you haven't already done so, download Vivado. Now, notice I have 2020.1, which I don't think is available anymore. I think they probably obsoleted it. That's what I have on my computer. But of course, you can have a more recent version. I think I mentioned in my email that last quarter, version 2022.1 and 2022.2, for some people, there was a bug. They had to make an adjustment in their settings. And I have that if you run into it. What the problem was is when they tried to open Vivado, it would just get stuck. Like it'd be like in an infinite loop that wouldn't actually open. So if you get that, let me know. It might be, you know, the fix that I have would be what you need. You know, if you have a laptop, please bring it to class and use your laptop. So it will free up as many of our computers for people that don't have a laptop. Again, I talked about Mac users. So once you have Vivado downloaded, watch that intro to Vivado video. That video takes you through Vivado, basically how to do the different steps. You know, it's like synthesis and simulation and implementation, all of that. You'll learn the different steps that you have to do. You know, the first few labs are fairly, now, I realize when you're first learning something, nothing's really basic, but relatively speaking, the first couple of labs are basic, but because you don't know the software yet, right? You don't know Vivado, you know, that's where the learning curve is, right? At the start. But then as we progress through the quarter, you become more proficient at Vivado, you know, and also Verilog, the language, but the designs get more complicated. Okay, so you know, the time issue at the beginning of the course is just learning the software, then the time issue towards the end of the course is more that the designs are more complicated. Okay, so any questions now? Like I said, you'll have some time on Thursday also, like if you run into problems downloading Vivado, you'll still have some time on Thursday to do it, but I wouldn't wait till then. Right? Because if you can get it on there before Thursday, that's always the best. And then I'll give you the rest of what you have to do for Lab 0 on Thursday, because you can't do the rest of Lab 0 until after the lecture on Thursday, because we'll talk about logic gates and like different ways to represent logic functions and things like that on Thursday. Okay? All right, so do you have any questions about anything today? Everybody good? Okay, well, that's it. And I will see you on Thursday.
You're welcome to give the class one partner up.
Yeah. I don't use Snapchat.